Good. Next chapter is related to ConfigMaps, and it's called secrets. Secrets are pretty similar to ConfigMaps in various ways. As we've seen, there are different kinds of secrets. The TLS secret is one particular example, where the secret has a particular structure to reflect the circumstance that you need two pieces of information to hand over to the ingress in order to terminate an SSL certificate. There's also a generic version, a generic type of secrets where you can again store arbitrary key value pairs. Now, the secret suggests that a secret is well stored in Kubernetes, and it is kind of like strange to notice that this is not the case. So in an ordinary Kubernetes cluster, secrets are stored plain text in the etcd. I think recent versions are changing that. There are definitely options to change that. So you could either encrypt the secrets with plugins, or you could even change the store from etcd, for example, to something else like Vault, which is a component of open source component from HashiCorp, to store secrets in an encrypted and more safe way. So the main advantage of using secrets is that you allow swapping out the secret store with something more secure, and make that a configuration option for the Kubernetes operator, and it's entirely out of the responsibility of the application developer. So if I'm running in a software company, I tell my developers, well, common sense, use secrets where sensitive data is stored, and then tell the operators to configure their clusters in a way that for production systems a safe secret stores used. Look, if the Kubernetes cluster is entirely owned by a smaller application or smaller organization unit, and it has exclusive access to that cluster, storing passwords in plain text is still stupid, and it's still a risk, but it's less a risk than if you were to share that with other people who could potentially escalate into looking into your etcd store and so on. But as a general advice, just because it's secret doesn't mean it's secret. But it's within Kubernetes, you know where to place your sensitive information, and it makes making it secret rather easy. Therefore, you should use it, although the default doesn't provide you a high level of security. Okay. So secret types. There's another option that you may encounter beside of the generic secret, which is the basically similar to a config map, just a set of key value pairs. The TLS secret, the one for the SSL certificates, and there's one for container registries. We are using Docker Hub for now, but if you were doing in-house development and you have to deploy a lot of container images, it may be an advantage to have your own container registry for two reasons. At least for two reasons. First, it is your container registry. You don't have to put your sensitive container image, if it's sensitive, somewhere where you don't have access alone, exclusively. So it'll be stored somewhere safe within your data center or within your AWS account or your Azure account or wherever you put this thing. And the second reason is it's local to your Kubernetes cluster. So you could place your registry within the same network, and you don't have to pay traffic for incoming. What would you pay for? I think you pay for outgoing traffic, right? Yes. So if, for example, you have two accounts and you download a lot of traffic, I think that will make a lot of difference. So maybe forget the cost argument, but definitely the speed argument could be interesting. So let's say you have a CI/CD pipeline and you have a container registry that is closely related in a private network with 10 gigabit of bandwidth to your Kubernetes clusters. Pulling images will be much faster, and it also won't create external traffic, which could be a positive side effect. So keep it in mind. There's another secret where you can tell Kubernetes to access external container registries. The way you'd provide Kubernetes access to them would be to store a secret. So you may use secrets for various other plugins you set up into Kubernetes cluster as well, because whenever credentials are to be stored, secrets are the way to go. All right, so as I said, the generic secret type is basically similar to ConfigMaps, key value stores combined into a collection of them with a name attached to it. TLS would be the SSL certificate. Docker registry is the unfortunate term for container registries because, well, that's a more generic term. Which brings us to the fun part. How to create a secret. It's pretty much the same like creating a config map. So you say kubectl create, it's a different kind. So it is a different entity, it's a secret. You have to pass the type of the secret, which is also different from the config maps. So this one is a generic, which behaves pretty much like a config map. We call it Area 51 because I'm pretty into bad jokes, and yeah, so Area 51. From literal, we are alone. We don't know. Actually, yeah, let's not get into that. Username, admin, from literal, password, and some arbitrary string. So let's create this one. And it will create pretty much what you expect. Kubectl get secret area 51. JSON. So it will create in the data section, as with the config map, a set of key values. Are we alone, password, and username. So from the key structure, I would say that this is straightforward because it's the same as with config maps. The one thing that you will notice is that this is not the value you've entered, and you'd be like, oh, it's encrypted, but no, it's not. So the secret behind that obscurity is it's a base 64 encoding. So we take that string and pipe it into base 64 minus decode, and there you got your value. So it's just a different representation for your string. It obfuscates the string. So but it's not safer in any way than showing the direct string, because you give me that and I can decode it without any other knowledge necessary other than it is a base 64 encoding. So it doesn't provide you additional security. So keep in mind, and also, and that's also a fun part, let's edit the secret. You'll encounter also the base 64 version of the string. So if you place here your string, you'll either create an error message because it's not a valid base 64 encoding, or you'll create a very strange undefined behavior because you're basically then piping the plain text into a decode. And as you can see, that produces a pile of garbage. So be aware that that secret values by default are plain text stored in a database. Plain text, I'm referring to that there's no encryption, but it's not plain text in the sense of it's the value you entered. It's a base 64 encoding. I'm pretty sure there's some thought behind that, but I don't know. I haven't looked into that. Yeah, so I'm pretty sure at some point I'll update on this, because I found why smart people did something that is apparently so unsecure. I would say that because securing that whole thing is a bit of challenging, because if you want to encrypt something, you need to have a key. If you need to have a seed that will also be the seed for encrypting everything. So that would make bootstrapping a Kubernetes cluster maybe more complex, or that the subsystem for securing your secrets will also be rather complicated and requires deciding for a particular implementation. Maybe you don't want that particular decision to be core Kubernetes, because one people would use Vault, other people would use CredHub, and others would be using a commercial plugin. So if you would, as a creator of Kubernetes, be agnostic to those plugins, then I understand that it's pluggable. I don't understand that the default is so insecure, to be honest. But that's opinion territory. Good. Editing a secret, we've seen that there's base64 encoding involved. I showed you how to decode, and well, you can also use the command base64 if you have set it up to encode it. So don't know. It expects a file, so I think I have to pipe it into it. Don't know. I just removed the decode. Yes, here we go. So that's just a thing that you have to keep in mind. It's not a complicated matter. So you can also retrieve a secret value. So in this case, we've retrieved the secret with the name area 51. As output pattern, we specify Json Path. So Json Path is basically very simple to explain if we have a JSON example. So this is basically a JavaScript data structure, a hash. It has a key data, and what we want is username. So if you write code, you'd be like, yeah, name of the object dot data dot username, or any other syntax, basically doing the train wreck. So with JSON Path, you basically do exactly that. You tell, well, within the hash, go for the data key and then for username key. And this is all I care about. So if you execute that, you'll get the base64 encoded value. And that you'll pipe into the base64 command, which is decoding it for you. All right, that's it. This is how you can retrieve and decode. For example, during debugging, you may want to check whether the secret is set properly, because, for example, if your service doesn't work or you can't log in, sometimes you have a white space in or near your secret. So for example, here you see that special character that also provides me the information that there's no new line attached to the string. So especially if you're reading from a file and the file has a new line and your code doesn't chop or chomp off the new line character, you could maybe take the new line character and then put it into your secret, and then your password actually contains a new line character. So I never run into this issue, or not recently, so I'm not sure whether there's any chomping applied to it automatically, but something to keep in mind. Okay, consuming secrets from applications would be the next hot topic. As you can imagine, it's pretty much similar to consuming a config map. So this was placed as an exercise. So use your knowledge learned during the config map lessons and create a pod, consume the previously created secret area 51 as environment variables. All right. So the hints are that we should use a secret key ref instead of config key ref. So let's look into so it actually is config map key ref. All right, noted. Little mistake here. So use secret key ref instead of config key ref. Use secret instead of config map. All right, so let's copy this thing. Copy 40 to, let's say, 80 secret 1.yaml. All right, so env. We still have to look into what are the keys of the secret. So that would be a password and username. Right, let's start with username. Config map secret ref would be secret key ref. That would be area 51. The key, the key would be username, I think. Yes. And password. We'd also call this one password. And qcutl apply it. Oh, I see. It's completed. All right. So here we also, this container again invokes the env command, so that in the logs we have, as expected, the username and the password mounted as environment variables. So as you can see, the secret chapter has not so much meat to it. As far as I know, you can also mount secrets as files, so it's pretty similar to config maps, with the difference that the entire way the secrets are stored within Kubernetes can be plugged plugged in and replaced with alternative implementations that are more secure. So take in mind that it is not encrypted by default, but it's definitely still the way how you should store sensitive information. So in the final exam, if you use a config map to store your passwords, I'd be reducing the number of points because it is a mistake. The reason for that is, as discussed earlier, if you're not using a config, if you're not using a secret, the provider of the Kubernetes cluster or the operator can change it, can't exchange it with a more secure implementation, which is possible with the secret. So if you do that at home, there's also a explanation. Next up would be jobs. I would leave that to the next lecture. Well then, thank you very much, and see you next time.